Dear student, this is for class 10 irrational number and lecture number 2. See, prove that root 3 is an irrational number. So we start the proof using the method of contradiction. What is method of contradiction? See here. If possible, suppose root 3 be a rational number. We have to prove irrational, but we have supposed rational. So must we get the contradiction? Okay. So suppose root 3 be a rational number, then this will satisfy the definition of rational number. Root 3 is equal to p by q. P and q are integers. Q is not equal to 0. And GCD means HCF, greatest common divisor, of PQ is 1. Under this condition, this PQ is the rational number. Now see, do the whole square both sides. This is 3 is equal to p square by q square. Then p square is 3 times q square. That means p square is multiple of 3. We claim p is multiple of 3. I am not going to prove this one. Okay. P is multiple of 3. Then this claim is true if p is not multiple of 3. If we prove p is not multiple of 3, then this will be multiple of 3. So see here again the contradiction method. Let p be not multiple of 3. Then p is equal to 3m plus 1 or 3m plus 2. When we divide some number by 3, then get the remainder 1 and 2 if it is not the multiple of 3. Very simple. Get 1 and 2 remainders. So either this form or this form. If this form is correct, then p square is equal to 3m plus 1 whole square. 9m square plus 6m plus 1. Again take 3 common, 3m square plus 2m plus 1. Okay. And 3, this is 3k. What is m here? M is integer. For some integer m. So see here. It is again in the 3k plus 1 form. So this is not form of the multiple of 3 because remainder is 1. So p square is not multiple of 3. Very clear? See, so this contradicts this one. That is p square is multiple of 3. So we get one contradiction. Second, p square is 3m plus 2. If you divide the p square by 3, remainder is 2. Then do the whole square. Again 3m square plus 4m plus 1 is there. And then this is plus 1. This is 2 to the 4, then 3 plus 1 I have taken. Splitted the 4 into 3 plus 1. Okay. So again it is in the form 3k plus 1 where k is integer. Here k is also integer. So see, p square is in this form in both the case. That means p square is not the multiple of 3 if p is not multiple of 3. Then p square is not multiple of 3. But what is given here? P square is multiple of 3. So these two cases not possible. So ultimately what is possible? P is multiple of 3. So our claim is correct. If this one is multiple of 3, then it will be p is equal to 3n form for some integer n. Then p square is equal to 9n square. Then 3q square is equal to 9n square. Replace p square by 3q square. So q square is equal to 3n square. Then q square is multiple of 3. Then as p square is multiple of 3, then p is surely multiple of 3. So q square is multiple of 3. Then using this technique we can say q is multiple of 3. So one you have done. Here it is not required for q. Only p is integer also, q is integer also. It is happening here. Now GCD of PQ is not 1. Why? Because q is multiple of 3 and p is multiple of 3. See, this is first, this is second. So from first and second statement, what we conclude? GCD of PQ is not 1. At least 3 will be, because both are multiple of 3. So we get the contradiction that this GCD of PQ is equal to 1. So this assumption is not correct. Then what is correct? Root 3 is an irrational number. Thank you. Enjoy.